I'm Sean Riley, and welcome to Honors Physics.
The first unit we studied in Honors Physics was Chapter 2, Motion in One Dimension, or simple kinematics. Mechanics is the study of an object's motion, and the kinematics is the description of how they move. One major component is distance versus the concept of displacement, where distance is the total length traveled, and displacement is just from point A to point B. There are 5 main values: final velocity, initial velocity, acceleration, time, and displacement. You need 3 of the values to find any of the other 2 values with 5 different equations. All the definitions and concepts are based on an underlying assumption that acceleration is constant. It only occurs in one direction, and this could also apply to free fall, with gravity equaling 9.81 meters per second. This is simple, like throwing a basketball up in the air and then watching it fall down with an acceleration of 9.81, which is the speed of the acceleration of gravity.
Lucas, yeah!
The second unit we did in physics this semester was projectile motion, also known as kinematics in 2 dimensions. Before you can understand projectile motion, it's important to understand vectors and scalars. A scalar is a quantity with magnitude only. Some examples include time, distance, and mass. A vector, on the other hand, is a quantity with magnitude and direction. Some examples of vectors are acceleration, velocity, and displacement. In projectile motion, you use the same 5 quantities as you would in regular one-dimensional kinematics, which are initial velocity, final velocity, acceleration, time, and displacement. The difference is that instead of using these quantities in only the x or y direction, you use them in both the x and y direction. Also, sometimes you have to take into account different angles and use some basic trig. Another important thing to know about projectile motion is the range equation. This is used in scenarios where the object travels ground to ground, and it really reduces the number of steps you have to do to solve the problem. And the equation is displacement equals velocity squared times sine 2 theta divided by gravity. Okay, so as a sample projectile motion problem, let's use an example of hitting a golf ball. You could find how far the ball traveled by listing the x and y stuff. For the sake of this example, let's assume that the initial velocity, launch angle, and maximum height of the ball are known. So first, you would use the launch angle to solve for initial velocity in the x and y directions. Then, using initial velocity, delta y, and gravity in the y direction, you would solve for time. Finally, to solve for distance traveled, you could use the equation delta x equals initial velocity times time plus 1/2 acceleration time squared.
Danger! Gone forever. Kenny's toe.
Another unit we learned in Honors Physics was energy, and on the side, work. Energy is defined as the ability to do work and is calculated in joules. The law of conservation of energy states that energy put into a system has to equal the output of the system. Work is the force applied to an object over a period of time. Back to energy, we learned about 2 different types of energy: kinetic energy, which is energy of motion, and potential energy, which is stored energy.